So today we're going to talk about the MDS monitor. I believe I've done this at least once before in a water cooler, but for one of our first walkthroughs, I thought I'd go through this. This is often a little mystifying. So what is the MDS monitor? The MDS monitor is part of the Ceph monitors. It's one of the Paxos services that we have. There are other Paxos services within the MONs, notably the OSD monitor and the manager monitor. What these different Paxos services do are to create an authoritative service for driving state change within the Ceph cluster. For the MDSs, they make changes to the MDS cluster by making modifications to the FS map or the MDS maps, and then distribute those MDS maps to all the clients and MDS according to what those entities have requested. Some entities like the MDS map or like the MDS only care about the MDS map for the file system that they're serving. Some clients may want to subscribe to the entire FS map to be able to see all file systems. And some clients will also, like the MDS, only care about an MDS map for a particular file system, which is generally the case. The other function of the MDS monitor is to monitor the health of the MDSs. It notates when MDS daemons are laggy, and it does that by adding that to the MDS map. And if an MDS continues to be laggy, then it may actually do a replacement by promoting a standby and kicking the old one out and blocklisting it. Finally, the MDS monitor is also there to provide a command interface for manipulating the FS map and MDS map via commands. So, like from the Ceph command line. For example, failing an MDS is really just removing it from the FS map, creating a new file system, creating a new file system and MDS map in the FS map, things like that. These are that. Yep. So that's everything the MDS monitor is for as far as purpose. Do we have any questions about that before we move on? Okay. So within the monitor, there are these components primarily. The MDS monitor refers to two given FS maps, and each FS map refers to one or more MDS maps. Well, actually, it could be zero or more if there's no file systems. Where the MDS monitor remembers the current official FS map, which I've marked E-1, epoch -1, and that is set in stone. It can't be changed once created, or once the monitors have agreed on what its current state is. So it's immutable. And then FS map E, which is the next FS map that the MDS monitor may be making changes to. Here I removed one of the MDS maps just to indicate maybe a file system got deleted, and that would be the delta between the two. And then there's this FS commands module within the monitor that is just an abstraction for performing a number of file system commands on the FS maps. For example, creating a new file system, or failing all the MDSs on a file system, or changing FS settings on a file system. Those are all routed through FS commands, which also modify the current FS map that's pending. You'll often see within the MDS monitor the next epoch is referred to as pending. The pending one is never shown to clients until it's finally distributed among all the monitors and they agree on the changes as part of their Paxos algorithm. So any changes to the current pending FS map are never revealed to clients or MDSs. It's only when they're when it's finally when consensus is reached by the monitors do we finally effect those changes, which may be sending an MDS that it's been removed from the MDS map, or updating clients about the new MDS map. So here's a look at the MDSs on the monitors, the clients, and what kind of messages we see between these entities. The big one is going to be from the MDSs to the monitors. They periodically send what's an MDS beacon message, which is really just a heartbeat message for the most part, being sent to the monitors, telling the monitors that the MDS is still alive. And that is sent, I believe, every MDS beacon interval seconds, usually about 2 seconds, I believe, from the MDSs to the monitors. And when the monitors receive that, let's say the MDS sends it to one of the peon monitors. It could be any of the monitors that it sends the message to, but generally once it picks a monitor, it stays that way for the duration of the MDS's lifetime, unless it loses connection to that monitor. The monitor that's the peon, assuming that the MDS sent it to the peon, would forward that message via an M forward wrapper to the monitor leader. And the leader actually is the one that's going to do any kind of necessary notations about the beacon. For example, is the MDS no longer laggy, or is there a state change that needs to be performed? And then it sends the response back to the peon monitor, which forwards finally the MMDS beacon ACK, the MDS. The beacon messages we're going to get into more later, but one of the reasons why they're very important when looking at the MDS monitor is that they drive state changes for the MDSs. If, for example, an MDS is in the replay state, so it just took over for a failed rank, only when it's done replaying is it going to tell the monitors, okay, I'm ready to move on to the next state. And it'll mark it as, gosh, get them all jumbled in my head, but like up resolve. And it'll request that the monitors change its state to resolve. Then once the monitors will, or the leader will drive the change in the MDS map to update its state. And then only once all the monitors agree that on the new FS map, Epic, will it finally respond to the MDS that, okay, you can go to up resolve. And that would be included in the MDS beacon ACK. Also, the monitors distribute MDS maps periodically via an MMDS map message. So those get sent to the MDSs whenever there's a MDS map change. Same thing for the clients of the file system, which I have in the top right. And then on the bottom left, we have this M command message, which would have something like a CephFS new or CephFS set or MDS fail, any of those kinds of commands which get sent to the mon. And if it corresponds to an MDS command that's handled by the MDS monitor, it would get processed there. So that's another kind of command we see dealt with in the MDS monitor. Any questions about this diagram?
I have one, Patrick.
Sure.
Is it always the leader that distributes the MDS map, or can a peon also do it once all the monitors have agreed upon the Paxos state?
They can all distribute the MDS map once they've agreed. So usually the MDS will pick a monitor at random, and everything it gets everything from that monitor, including the MDS map. The leader doesn't need to get involved in distributing the MDS map to the MDSs, and that's one of the nice things about having several monitors is you can actually distribute that load out. So yeah, the leader is not involved in that.
Okay, thanks.
Any other questions? All right, so we're going to look at some code, and I will need to change what I'm sharing. So stand by. And I will also, can you all see my code?
I can see that the console just appeared, but it will be better if you could possibly increase the font size.
All right, let me also get a link for everyone to view the slides. And hopefully that link works. Let me know if it does. Anyone able to try the link?
You need to open it up, I think, permissions-wise.
Okay.
That font size you just set is legible for me. I don't know about others.
That looks good to me.
All right. I updated the permissions. Hopefully it should work now.
Yes, now it works.
Okay. All right. So the first bit of code we're going to look at is called the Paxos Fs Map, and this is fairly new code in the monitor. I think I added this like 2 years ago. And the reason we're starting with this is that it's kind of unique to the MDS monitor, and I think in retrospect, if we were starting the monitor from scratch, we'd probably use something like this throughout all the monitor services, because this is one of the most the thing that gets screwed up the most in the monitor and causes all sorts of problems. That is, I mentioned in the diagram, the current epic that is, that has been being distributed to MDSs and clients and is immutable, is stored in the Paxos service, like the MDS monitor. And well, sometimes people write code and they accidentally modify the immutable FS map. And that causes all sorts of problems. It doesn't do what they expect. And sometimes changes get lost, etc. So what I did was I added this class which just protects the current FS map and then what we call the pending FS map, so the next epic. And the Paxos FS map is inherited by the MDS monitor. If we take a quick look at the MDS monitor, you can see it's actually inherited by this MDS monitor class. Coming back to that code. So this is private. It can't even be accessed with these members. FS map and pending FS map can't even be accessed by the MDS monitor class. The only way to get at these members is through the methods, and we have getters for the FS map and then also the pending FS map. These are public, so they can be called by, for example, the OSD monitor, which does happen in like at least one place within the OSD monitor. It actually needs to look at the FS map. But when it does use these methods, it only gets a constant version of it, so we can be fairly certain that it's not changing it. And we're not aware of it. The protected methods are designed to be used by the MDS monitor itself. So here's how it actually gets a writable version of the MDS map, and it can only get a writable version of the pending FS map. And we have a check here to make sure that this is the leader monitor that's doing the changes, so that we don't have a code path that somehow, as a peon monitor, is somehow changing the pending FS map, because that's never what you want to have happen. And then we have two methods here which actually create the next pending FS map. So the leader, anytime it's finished distributing the new FS map to the other monitors, it'll create the next one through this the next FS map through the create pending, and that just makes a copy of the FS map and then increases the epic. And then we have this decode method, and this will primarily be called by the peons. So whenever it gets a new FS map from the leader, it's going to decode the buffer list, update its current FS map, and then also null out the pending FS map to make sure that there's no invalid accesses to it. Because again, the pending FS map should only be read and written to by the leader. So we have these protection methods in, and there were a number of changes that had to be made to the MDS monitor to use this, but overall, this actually turned out to be a very positive change, I feel, because it actually caught a lot of bugs and is preventing through code any number of new bugs. But again, this is fairly this is a unique protection to the MDS monitor. You're not going to see this in other services. All right. And then just to look at the MDS monitor side of this. So again, the MDS monitor is a Paxos service. So there's two methods we should look at for the MDS monitor as far as this Paxos Fs Map is concerned. The first one is update from Paxos. So this would be called, for example, by the peons. Once it gets an update to the FS map, it goes through this code, and here it's just getting the next version of the FS map, so it's getting it in a buffer list. And then finally, we're going to call this Paxos Fs Map decode method. And that'll update the peons version of the FS map. And here we print it out. And if you look at the monitors, you'll periodically see the FS map get dumped out to the debug log, and that happens here. And in fact, it happens at a very low debug level. So even on clusters with all the debugging set to the lowest defaults for the monitors, you'll still end up seeing these new FS maps get printed out in the monitor log, so you can rely on that being there. And then here's a call to check subs. So anytime the monitors update the FS map, they also need to notify all the clients who have subscriptions to MDS map, and they will go through all those and update that. We'll take another look at this later. And then the final method we were going to look at relating to the Paxos Fs map is create pending. So again, this would be called by the it is just one of the abstract methods in the Paxos service class. So whenever it's time to create the next map that the Paxos service is distributing, it calls this create pending method, and so that would happen after all the monitors have consensus on what the current version of the FS map is, and then the leader is going to create the next pending one. So that happens here. And again, this is wrapped up in this Paxos Fs map precisely to prevent the MDS monitor code from creating a new pending map anywhere except here. All right, that's the Paxos Fs map. Any questions about that? All right. So the next code to look at, as I mentioned earlier, the beacons are what drive most of the state change that's automatic in the MDS monitors, and these come from the MDSs. And so the first method that's going to be called whenever there's a beacon is this preprocess beacon method. And that happens both in the peons and in the leader. So as the name of the method suggests, we're just doing some basic preprocessing on the beacon prior to actually doing any changes that would be a result of that beacon. So for example, here's a simple permissions check that even the peons can do. If it's not an MDS with this XCAP, then the beacon's got insufficient privileges. We're just going to ignore it. And here we're going to check that the FS ID for the Ceph cluster matches what the message has. So is this an MDS that's actually supposed to be part of a different Ceph cluster? Things like that. And then some compat checks. For the most part, these result in just ignoring the message. The peons don't reject messages, and this is actually kind of sometimes a problem within the monitors is that if something goes wrong, the monitors just ignore it. And so what you'll end up seeing is a client that hangs, and because it's expecting a response from the monitors that it's never going to receive. So this is either, it can be a good thing or a bad thing, depending who you ask. Having confusing hangs, in my opinion, are kind of a bad thing, but that's something that's kind of prevalent in the monitors, is that there's a lot of the default behavior for handling a problem is to just ignore it. So you'll see that. And then here's the key bit in this preprocess message. If it's not the leader, if this monitor is a peon, then we're just going to return false, and that just indicates to the caller of preprocess. Let me see if I still have this code open. Yeah, so preprocess query is one of the MDS monitor methods, and you can see it just calls preprocess beacon below if it's a message beacon. When the Paxos service calls this preprocess query, if the return value is true, that means that it was processed, and there's no further work necessary as far as preprocessing for the message. But if it returns false, which for the peons will generally always be the case, then the beacon needs to be forwarded to the leader. And that is handled here in the Paxos service code of the monitor. If it's not a leader, then it's just going to forward that request to the leader. And so further processing will happen on the leader. So if you're trying to debug issues with changes to the MDS monitor, you generally always need to be looking at the leader and not on any of the peons, because all the beacon processing, all of the file system commands are eventually going to be processed on the leader. So finally, when the leader does get the message, it's also going to go through this preprocess business, and then finally do some basic checks on the beacon. So, like for example, if the GID of the MDS does not even exist in the current FS map, then and it's not asking for the boot state, that is, it's not a new MDS, then we're just going to say that the beacon's not an FS map, and we're going to send it an empty MDS map, which will cause the MDS to respawn. That could happen periodically. For example, if the MDS gets kicked out for being laggy because there was a network partition, and then it comes back 20 minutes later, thinking it's still in the MDS map, and the monitor says, no, you're not, and it sends it an empty MDS map to cause it to reboot. So for the most part in preprocess, we're not doing any kind of work on the FS map. You'll see this is all access to this. Go back up to the top of this method to show you. Here we do this get FS map call. And as you'll recall from the Paxos service, Paxos Fs Map, that is this method. And so we're just getting a constant version, a constant reference to the current FS map. And so it can't be modified. And we're not calling get pending. FS map, I don't even think we call this method is used in, yeah, you can see that in MDSMonitor.cc, we don't even call get pending FS map. We only call get writable. And you can actually see exactly where in the MDS monitor that we get this reference. So it's not in preprocess beacon. We're only using the existing FS map. So we're not making any changes to the FS map in this method. We're just doing basic preprocessing on the beacon. For example, if the current version of the MDS is laggy, we're going to definitely note the beacon. And you'll see this called in a few places in the MDS monitor, which is basically just saying, doing some internal bookkeeping in the MDS monitor, saying that the MDS has been seen recently and should not be considered laggy as of this time. And the interesting bit about that being in the preprocessing is that we want to preprocessing is done, I believe, with the fast dispatch. So it's done basically as soon as the message is read off the wire, and that's important to prevent an MDS from being marked laggy and being removed from the cluster just because the MDS or just because the monitor is under load. Maybe it's getting is doing a lot of work of some kind. Maybe it's getting a lot of messages. Something's slowing down the monitor, and you don't want your MDSs to get kicked out just because the beacon messages are not being processed quickly enough. So that's one of the functions of preprocessing, and you'll notice that especially if you look back in the history of the MDS monitor code, there's been numerous changes to try to avoid that particular situation of the MDS monitor falsely believing that the MDSs are laggy or disconnected and then removing them. So that's been a recurring issue in the MDS monitor code. And then there's various code here to check if there's going to be a state change, and eventually, if there is, we're going to actually send an ACK message back and then finally do some further processing on it. And the further processing is going to be done in prepare beacon. So this is where we're actually going to make state changes to the FS map potentially, and because of that, we're going to get a writable reference to the next FS map, and so that's what this pending reference will be. All right. And so there's a few things that prepare is doing. It's going to record the health checks from the beacon. So every time the MDS sends a new beacon, it will set all of its health checks in it. For example, if it's got an oversized cache or a client is not releasing its caps fast enough, you will see those messages in these what we call these MDS metrics, and the monitor is going to look for differences and actually note those. Like for example, in the cluster log, for example, this MDS health message was cleared, and all that work happens here early on in prepare beacon. And then finally, the MDS monitor is going to look for state changes. So is this going to be a brand new MDS map? So when an MDS first boots, it's going to send the state boot to the monitor. And here we're checking if there's one condition, MDS enforced unique name, which is by default true. So if there's another MDS with the same name as this one that's claiming to boot, then we're just going to go and find the old version, old MDS instance with that name, and we're going to kill it. So as part of killing it, you have to blocklist it. So here we're waiting to see if the MDS monitor or the OSD monitor's OSD map is writable. If it is, we're going to blocklist it. That happens in fail MDS GID. But if it's not writable, and that's just corresponds to machinery in the monitors about whether or not you can do a write at the moment to the pending OSD map, then we're going to wait for it to be writable and then retry this beacon message. But here we actually fail the MDS with the current, or the instance with that name. So there's various bookkeeping here for the beacon. Here's the else for the if on whether it's a boot MDS, and that means that there's some kind of state update potentially. So here again, we're checking if the GID exists in the pending FS map. Maybe, for example, we have a MDS fail command was issued, and the MDS got removed from the next FS map, and at the same time as that's occurring, the monitor is also looking at this a beacon from that MDS. So in the pending FS map, if that MDS has also been removed, then it's going to hit this code path, and it's going to need to wait for the current FS map to be distributed amongst all the monitors. It's to reach consensus, and then it's going to send execute this lambda context to send an empty MDS map to the MDS that sent that beacon. So that would be the situation where we would hit this code path. And then finally, the interesting bit here, some of the interesting bits. So here we're going to clear the laggy state if it was laggy. And moving on. Here's where we're handling some of the various states. So if the MDS is stopped, that means that the rank is down. So the MDS was in the stopping state, and then it says it's stopped, it's finished. So here we're going to add this to, we're going to call this FS map stop method on this GID. And that just does, the FS map will do some bookkeeping to record the rank as stopped. And then we just remove the stop GID from various bookkeeping structures in the MDS monitor. And here is an indication that the rank is damaged. So again, we're also going to blocklist the MDS. So we're going to check to make sure that the OSD monitor's OSD map is writable. And then finally, we're going to blocklist or mark that the rank is damaged here in the pending FS map. And I'm looking for where we blocklist the MDS, and maybe we don't, because it's presumably going to shut down on its own. So I'm not sure why this check was here to begin with. That might just be unnecessary. Here we go. We're calling the OSD monitor's blocklist method directly on the addresses of the MDS that sent us the damage notification. And that's just to handle the case of the MDS sends a damaged message, but then somehow continues operating. So the monitors want to make sure that it's dead. Do not exist. So that we would get this state if, for example, the MDS was failed, or rather terminated. So it got some signal like big term, and the MDS is just going to tell the monitors, hey, I'm going away and I'm not coming back. And that allows the monitors to immediately do a replacement rather than the MDS just going away, and the monitors have to wait for the full MDS heartbeat grace time period, which I believe is by default 15 seconds. Excuse me. And then at that time it would do the replacement. So instead, the MDS immediately just sends off a beacon to the monitor saying I no longer exist, and the monitors are going to blacklist it, and then let the MDS know that it got the message. So it sends a beacon back saying that it got it, and then the MDS would finish shutting down, for instance. The next big one is going to be, just scrolling down a bit, this one. So we're going to check that the MDS is not currently in standby state, and the state that the MDS is requesting is not equal to its current state, and then we're going to make sure that the state transition is valid. If it's not valid, then we're going to make a note of it, and then not do anything. And then here we're going to modify its state according to whatever it requested. And then finally, after making any changes to the pending FS map, we have to wait for the finished proposal. You can't tell the MDSs about a change to the state of the FS map until it's actually complete. So you have to wait for the finished proposal on the pending map, and then finally you can send out the reply. All right, any questions about beacons?
Patrick, I wasn't able to understand why we need to notify the OST monitors about changes in the MDS map.
So the reason for that is all of the block listing in Ceph is done by adding to the block list of the OST map. So if I want to block list an MDS so that it can't access the OSDs anymore, I need to update the OSD map by adding it to its addresses to the OSD map block list section. And so whenever I need to block list an MDS, I have to wait for the OSD monitor to be writable. Does that make sense?
Okay. So because MDSs are are also OSD clients, so you want to block list them. Okay. Right.
Yeah. Exactly.
Okay.
Any other questions about beacons? All right, the next one is prepare command. This corresponds to prepare beacon. So here we've got a mon command. So this is basically a message that's wrapping up some API requests to the monitors. This would be the message that carries, for example, MDS fail command or FS new or FS set. Any of those commands get wrapped in this mon command message. Here we're getting the command map from the JSON, getting the prefix of the command, which would correspond to, say, MDS fail, getting the session, ensure it has sufficient access. And then here again, we're getting the pending FS map, because as part of doing these commands, we're going to have to make changes to the FS map. And here we're going to a number of handlers to see if we can process those messages there. These are going to correspond to what's in the FS commands class, and we'll get to that in a moment. And so this is just some common handling for as an abstraction for handling those commands. And if we can't, then we go to this poorly named method command, file system command, which has really just become an MDS command method. If we go to that, you'll see that most of these commands that we're handling, if the prefix is, for example, MDS set state, this is some of these are just development commands that aren't worth talking about. Let's talk about MDS fail, because that's something people actually run. So here we're getting the role or GRD argument, and then checking are getting the GID from that argument by calling this GID from arg helper method in the MDS monitor. And if the GID doesn't exist and we complain it does not exist, various checks, and then finally fail the MDS, which is something we call throughout the MDS monitor. And fail MDS, I believe, will return a failure, E again, if the OSD monitor is not writable. And if that occurs, then we wait for it to be writable and retry this message. So the check for the writable OSD mon it happens in fail MDS in this case. So all these just make changes to the pending FS map. All right. Next, let's talk about pick. So this is a method in the MDS monitor that's just periodically called, like approximately every 5 seconds, I believe, by the Paxos service. It just lets you do basic upkeep on the FS map. So here we're again getting the pending FS map writable handle, and we're going to just do a number of checks on it. So for example, here we're going to check health. This is just going to make sure that the MDSs are healthy. I believe it's going to just check if any of them are laggy. So here we're actually checking whether an MDS actually timed out. Make sure it's fully populated. So you'll see again, like as I said before, the beacon noting when to remove an MDS because it's timed out is actually fairly complicated, and there's been a number of changes over the last decade to the monitor to handle various corner cases of MDSs going laggy. So that's all handled here. If one of them is laggy, then we're just going to remove them. So you have this vector of GIDs to remove. And you'll see the various notes. For example, this one's being marked laggy, and this one is going to be removed. And then here we actually go through the to remove vector and find replacements for those MDSs and drop them. So that's handled in check health. And then here's another one to resize the cluster according to max MDS. So that happens in this method, maybe resize cluster. And here you'll see, for example, we check if the current MDS map is resizable. Current MDS map is from here. We get the FS map, get the file system, and get the MDS map. So we want to actually check if the current epoch of the FS map is resizable. And then MDS map corresponds to the pending FS map. So you see this FS map is the writable handle here. And then this method also wants to look at the current epoch as well. So it gets a handle to the current MDS map. So this is the pending FS, and then this is the pending MDS map. The names could perhaps be improved. So we're just making sure that if either the current FS map is resizable or the pending FS map is resizable. If neither is true, then we're going to say that the MDS map is not currently resizable. We're not going to make any adjustments to the number of MDSs in the cluster based off of max MDS. Otherwise, we look at, for example, if the number of in MDSs is less than max MDS, then we're going to try to grow the cluster. And here we would find a replacement by asking it to fill in this rank. And if the FS map's able to do that, then we're going to promote it. Find a replacement for the rank and then promote it to that given rank. And then we're done. The MDS monitor at one point actually allowed you to promote several MDSs. So if I set max MDS to 10, it would try to promote like 9 MDSs all at once. to all of those ranks if it had sufficient standbys available. Behavior like that turned out to be a source of bugs. So at one point we changed it so that things happen in a sequential fashion. So now the MDS monitor will only promote one rank, and then it's going to wait for all those ranks to be active, and only then is it going to add one more MDS to the cluster. And that's also true of stopping. We had a lot of issues with multiple MDSs trying to stop at the same time that found all sorts of weird bugs in the MDSs. It turned out to be just simpler to have only one MDS stop at a time. So for shrinking max MDS, the MDS monitor will only stop the largest rank and wait for it to fully stop, and then it moves on to the next highest rank and stops that rank. So that happens in this method, maybe resize cluster. And then finally, we go through again and look to maybe promote any standbys for failed ranks. So if a file system has a failed rank and it's waiting for a standby to be promoted, that would happen in this method. And if as part of doing this, we also have to propose a new OSD map, that would happen, for example, if we failed in MDS. Then we need to also do a block list and update the block list. So we also have to request a proposal for the OSD monitor. All right. He is very angry. Next, let's look real quick at check sub. So here, this code is looking to see if we can, I think this was done in like 2011. It's going to update the clients of the monitors with the new FS map. So anytime there's a change to the MDS map, the peons and the leader of the mons will send out new MDS maps to the clients. The code path that's going to get hit the most often here is this one. It's going to, we have a sub that's requesting the MDS map. And so is it a client? Is it requested a particular namespace? So if you recall in the kernel client, we referred to file systems as namespaces. So that terminology leaked into the MDS monitor at the time all that code was written. And here it's going to look up the file system and then find the FS CID. That's what this code path is. These code paths are really looking for. And then once it has it, the FS CID is going to send it off the MDS map corresponding to the FS CID. So here's the lookup where it gets the MDS map. And then finally that gets sent in this make message MMDS map and shipped off to whoever is asking for this subscription. All right. Any questions about what we've gone through so far? All right, so we talked about beacons a lot, so I thought we'd finally look at what a beacon is. And there's not a lot to say. It's a fairly simple message. Probably the most complicated part about this message is the number of health warnings that we've got in here. These, what we call these MDS metrics, and these get shipped off to the monitors. The message here, the main bits that are interesting here are the name of the daemon. So every MDS has a unique name. The daemon state, so this would be what the MDS is saying it wants its next state to be. In the steady state general case, it's going to be asking for the active state repeatedly, and nothing will change. And here's the MDS health metrics that it includes, and then also the file system for the MDS, or the file system name. And then also one last thing, sequence number, which is going to get bumped every time the MDS sends a new message, a new beacon to the monitors. It sets the sequence epoch so that it can keep track of what the monitor has seen so far. And that's one of the ways it can tell if it's being got a laggy connection with the monitors. And then also the beacon class. So this is a class that operates outside of the MDS lock for the most part. And this is just going to be doing things like handle MDS beacon. So whenever it gets an acknowledgement from the monitors for its beacon message, it gets an MMDS beacon back. And in here it's just going to note like the sequence timestamp for the monitor sent back and detect whether it's no longer laggy. For the most part, beacons are sent through this send method method, and predominantly these are set by the sender thread that's initialized in beacon init. And so every interval seconds, it's going to call this send method, and then just wait to send the next one. So again, this operates outside of the MDS logs. So you'll see regularly in the MDS logs the MDS's beacon class is just sending off a new beacon to the monitors. And here it notes the sequence that it's sending, updating the last sequence number, setting health metrics on the beacon, etc. And again, because I was telling you we're trying to avoid if the MDS or the monitors are under load, we don't want it to delay beacon processing. So you'll notice I can't find it. All right, so here's fast dispatch. So whenever we get a beacon response from the monitors, it's going to fast dispatch this handling. And that's one of the reasons this operates outside of the MDS lock, because you should not acquire mutexes as part of fast dispatch. All right. Any questions about beacons? We have 7 minutes left. All right. Let's talk about the file system commands. So again, when I was going through the MDS failed handling, I noticed that there were a bunch of handlers that could handle a given M command message. A lot of the file system handlers were moved to this FS commands class, and that was just to simplify a lot of the repetitive code that happens, like batch proposing and actually requesting a new proposal. All that code was abstracted out, and we have these classes now. Here we have like a few methods to check whether we can handle a given message, or is an operation even allowed. That's perhaps the interesting one. Here is op allowed. This was based off of some of Rishab's work recently to add an authorization to the CephFS caps that say which file systems a client has access to, can even see that MDS map for, and that's here. So here we're getting a copy of the current FS map, and we're filtering it. And we're filtering it based off of what the session is allowed to see. So if it can only see a given file system name, this filter method filters out all the other file systems. And then after that, we check whether it has access to that file system by trying to get it. If the file system doesn't exist, perhaps because it was filtered out, then we return an error message that the file system is not found, with some exceptions if it's a FSRM command. So that's one of the examples of abstract handling there. So, and just to look at a given file system handler, Usually when writing a new one of these, it's mostly just an exercise in copy and paste. They're templated pretty well. So here we're checking if the OSD monitor is writable, because this fsfail command, what it's going to do, if you're not familiar with it already, it's going to take every rank in the file system, both the rank itself and any standby replay daemons for that rank, and it's going to remove them all from the MDS map, effectively failing them. So as part of doing that, you have to block list. So it's going to check that the OSD monitor is writable. If it's not, then we have to wait before we execute this command. If it is writable, then we're going to get the file system associated with this FS name. And then we're going to mark it not joinable, so no new MDSs can join the file system. And that would prevent, for example, the MDS monitor tick method, when it's going through the file systems looking for failed ranks. It's not going to promote any ranks because any standbys to a given rank, because it's the file system is marked not joinable. I'm going to modify the file system with this lambda function that we created, and then actually fail each rank. So we got to get a vector of the GIDs, and then for each one of those, we call into the MDS monitor to fail the MDS GID, and then propose pending on the OSD monitor, and that's it. The interesting thing here, this is really a C++ thing, less a Ceph thing. Here we're getting a vector of the GIDs we're going to fail, and then pushing them back into the vector. The reason for doing that is you don't want to modify this map that's returned by get MDS info. You don't want to modify it by removing MDSs during the traversal. So first you get all the GIDs, and then you iterate on that copy of the GID vector and fail each MDS. Okay. Any questions about what I've gone so far? We have one slide left, so I'll switch back to slides. The right one. You all can you all see the last slide?
Yes.
All right. So just some of the interesting history that happened in the last 10-ish years. In 2020, we added the MDS affinity. That's the MDS join FS config that MDSs get set with. That's being used both in CephADM and Rook to indicate which file system an MDS is been created for. And that's just to simplify the previous situation we had. So CephADM was creating MDSs with very specific names, and the names also included the file system that the MDS was created for. And it was really weird to have those MDSs join other file systems. So it looked like just a mix, and it was really hard to track, whether or not you had stray MDSs or not, and all that. So, and you also may want to have MDSs with different hardware for a given file system. So this config setting was added to support that. 2019, we added allow standby replay. That was to simplify some config settings we had, like where you had to specify that a given MDS was allowed to do standby replay. And that was really confusing because generally you wanted to set that on all of them. And really, it made more sense of the file system flag. So this file system flag allow standby replay was added. In 2018, we added the Paxos Fs Map, so the get writable FS map methods and all that. That's when those protections were built in. In 2018, we added, Doug actually did a lot of this work, was the incremental mon-control deactivation. So we don't stop a bunch of ranks at once. If you reduce max MDS to 1 from like 5, you don't try to stop ranks 1 through 4. You just you do it in an incremental fashion. That proved out to be an extremely big stability win for multi-MDS. 2017, to 2018, you'll see a lot of changes in the MDS monitor trying to fix some issues we kept seeing in upstream QA with beacons being lost or not being recorded properly. So we had tons of messages and QAs about MDSs being replaced because they're laggy. There was a lot of code churn there. And I think there's still maybe a few latent bugs, especially when the MDS is talking to a peon monitor. Some of the beacons are not being processed quickly enough for some workloads, and it's causing the MDSs to be removed falsely. So I think there are some latent bugs that need fixed. 2017, last rank deactivation. Oh, I may have these mixed up. 2018, the incremental mon-controlled activation, I should say. So you increase max MDS, it only increases MDSs incrementally. Last rank, I think, was the stopping change. Anyway, it's a mix of code there. And then 2017, the FS commands was added, and that corresponded roughly with the 2016 changes that John did to add multiple file system support. So all that was done fairly recently. 2013, allow new snaps. This was in response to a number of bugs that were suspected with snapshotting in file systems. So Greg Farnham added the allow new snaps setting on file systems to prevent to indicate that new snapshots were allowed to be created on a file system. And we were also used that setting to detect if snapshots were ever allowed on a file system. And we needed to do certain upgrade checks or certain upgrade sequences in order to upgrade a file system that had snapshots at one point. In 2011, standby replay was added. It was fairly long ago that this feature has been in CephFS. And only recently, I think, became more usable. Just with this allow standby replay setting, it became much easier to set up. And then in 2009, subscriptions were... Ceph has always had some kind of subscription to the MDS map by necessity, but a lot of the code to create subscriptions was back then. And that's about as far back as I went. And if you look at the code of the MDS monitor, you see like at least half of the commits are trying to fix weird consensus bugs or beacons being lost in certain code paths and or not being recorded properly, and so the monitors falsely believe it. Okay. All right. That's it for the slides. Any questions about the MDS monitor before we wrap up?
Does MDS map, MDS monitor try to store anything persistently like FS map, or do they need to be stored persistently?
Yes, absolutely. All the monitors have their own store where they keep the MDS maps, and with some look back, eventually things get garbage collected after a while, so it doesn't remember every MDS map it created. The actual machinery for storing the MDS map is handled at a higher level than the MDS monitor. So it doesn't need to actually worry about the details of saving the MDS map to a persistent store. That's handled by other parts of the monitor. And yeah, that's all I'll say about that. Any other? Does that make sense, Romano, or any other follow-up question?
Yeah, that makes sense. Yeah, so monitor has its own persistent storage system. Okay. And the other question I had is, when you make any changes to the FS map and you get a new version of FS map, the pending one, and so automatically the MDS is subscribed for it, and that's how they know the change because they keep subscribing, or the monitor sends those messages to the MDS saying that the map has been updated.
So there's different kinds of subscriptions. One is that you might just want the next epic and you don't care about any follow-ups. And then there's other subscriptions where you just want to be continually updated for all versions. And the MDS is what will do the latter.
Okay.
I haven't looked at that code very hard, so I may be wrong on the details, but I'm pretty sure that's how it works. It may be that you just need, every time you get an epic or a new MDS map, you have to just ask for the next one immediately. But I think in order to reduce the traffic on the Mons, that probably was changed to just be automatic.
Yeah, thanks, Patrick.
Sorry about Craig is not very happy right now. Any last questions? All right. Thanks everybody for attending the walkthrough. I'll see you all tomorrow. Bye.
Thanks, Patrick. Nice talk.